Everybody was okay with the parabola? Remembering back, the parabola is the only one that uses a directrix. It's the only one that has a directrix. It has one focus and a directrix. And if it asks you to do your intercepts, make sure you set y equal to 0, make sure you set x equal to 0, and you give me your intercepts. I don't think I asked your intercepts on this one, because there was quite a lot to do, so I don't think I asked your intercepts on this one. Your hyperbola, oh, okay, ellipse first. We know this is an ellipse because it has, both of them have the same sign. Both of them are the same sign, so they're going to be an ellipse. And both of the coefficients are different. So it's not going to be a circle, it'll be an ellipse. So we get your x's together, your y's together, complete the squares. Can everybody get here? Everybody good with completing the square? Okay, now, in an ellipse, if you remember, it doesn't matter what order we add. So the larger denominator will be the a. That will be the major axis. So squared on top, squared in the denominator. So 16 squared, 16 is a squared. So a is 4, b is 2. So that means it's more oblong from the y-axis as a translated y. So find your center. Use a squared minus b squared, your foci, are inside your ellipse. I'm actually going to give you these equations to help you out.
The hyperbola and ellipse?
Yeah. I'll give you like a format like I did on the test part for it, and I'll give you the c squared thing. I'll give you that. I won't give you the formulas for foci, but you should know how to get there from your parts to that. Are there any questions on this part? We don't have to do your intercepts on this one. We do it on the parabola one because we have nowhere else to draw this to. But the ellipse and the hyperbola, there'll be no intercepts on those guys. Because once we make your ellipse or you make the box to make the asymptotes, we know where we're going. Just the parabola would have an intercept. And again, if it asks you for the intercept on the final, then you give it to me. Okay, this we know is going to be a hyperbola because the two sides are different. Now, we don't necessarily know that the x squared will be the major until we get to the end. If you noticed over here, this is going to be a negative over here. So we have to divide everything by a negative, which switches these signs around. So now y becomes your major axis. In a subtract, it matters who comes first. That's the major axis. So a would be 2, and b would be radical 3. And your c squared equals a squared plus b squared, because you want to push that foci outside of that box. You kind of set it up the same way as you do your ellipse, but you make a rectangle, send your asymptotes through it. Remember to give me the formula. I'll give you the formula for the asymptotes even. And that would probably help you out. Find me the center. There's technically no coverticity here, but you still just need to plot them so that you can make your box. Good? You have no questions? And the last one was just put this into standard form. And we could tell, you could kind of tell right here, they're both the same, and their coefficients are both the same. It's got to be a circle. So when I divide, I'll be dividing by the same thing. Whether you leave it like this, or you divide both parts by 7, and give me the formula for the ellipse, it's okay, because an ellipse, a circle is a special ellipse. I would prefer the circle formula, but if you divided it, not a big deal. Just put it in standard form.
So I know how to tell the difference between an ellipse and a parabola, but what about a hyperbola? How do you know?
The hyperbola has an x squared and a y squared, but it has a minus. They're both different signs. Like here's your hyperbola. the signs have to be different. It doesn't matter which one is negative, which one is positive, they just can't be the same sign. If they're both squares and their coefficients are different and they're the same sign, then you have an ellipse. But this will be a hyperbola. Parabola only has one square, like we saw yesterday. A y square will open sideways, an x square will open up and down. Good? Okay. Then I gave you 8. 8 had like a variety of things here. And we started some of them. You factor completely. Everybody okay with the factoring? Can you do 8 times 8? No. Guys, can you do 8 times 8? Factor? Okay, let's factor. First thing we notice is everything contains an x. Get the x out of there. Then you're left with this. Let's pull this out and do this separate. We have time. Okay, we're going to factor out an x first. Now you have a regular trinomial. Yeah, you can play with the factors if that's what you want to do. Or, what works every time is a times c. The first term times the last term. So 6 times 4, this will give us 24. You want to break down factors of 24 so that it adds up to 5x. So what factors, was this a negative? Did I write over this negative?
Yeah.
Okay, sorry. I'm saying, I didn't think that was going to work. So a negative. What factors of negative 24 would add up to 5x? 8 and negative 3. Doesn't matter what order you put them in. Just plot it with an x. This is going to replace this 5x. Again, it doesn't matter what order you write it in. Then you bring down your 6x squared. We're going to hang on to that x for later. And plus 4. Work on the first two terms. Group them and take out a common factor. So what do they share?
2x.
2x. Good. And what's left when I factor out a 2x?
3x plus 4.
Good. Now, I want to factor something out of the next two terms to make it look exactly like 3x plus 4. Okay. But, oh, okay. Hang on. My mistake there. This should have a minus because I made a mistake and forgot to change the minus sign. Because it won't work otherwise. So, I want it to look like 3x plus 4. So what can I factor out of there? A negative 1. Good. Your goal is to make these two the same. Once you have a common factor, you factor it out. And what's left is the other factor. Now, if it says factor completely, we have to bring this little x down that we forgot before. We factored him out before, so this is a factor completely. If it says solve by factoring, then if it says solve by factoring, you're going to set it to 0. It would probably have been set to 0 up here. And then you're going to put each one of these set to 0, right? Okay. Good? Determinant. Determinant, we said, if it's a 2 by 2, you have to do it algebraically. So you're going to multiply upwards. So 2 times 5 is 10, and 4 times 3 is 12, and the rule is subtract. So you're going to subtract them. This is your determinant. Now, if you remember back to your calculator, we're going to put in a determinant for this guy. We're going to put in a matrix. Second matrix. We're going to go to edit, and it's a 2 by 2. And all you have to do is plug your values in. 2, go across, 3, 4, 5. don't forget to quit. You have to quit to go back to your matrix. When you go back to your matrix, you're going to do, oh my goodness. You're going to do a calc on this. You're sitting right there at the determinant. So just go back and hit the matrix that you just entered in, A, and it'll give you your answer. This is a good way to check. If you forgot to subtract and you added, as soon as you put it in on your calculator, you'll see that, oops, I should have subtracted, not added. So erase the little add and make it a subtract. You can kind of cheat a little on this one. All right. And the next one, systems of equations. I want you to solve it algebraically, and I want you to solve it with your matrix. So for every variable that we have to solve for, we need an extra equation. So one equation, one variable. Two equations, two variables. Three variables, I need three equations. But I noticed, and we looked at this yesterday, that this didn't have a z. So if we could combine these two, and if it helps you, label them. If we can combine 1 and 3 and eliminate the z, you have to eliminate the same one. Then I can combine that one with 2 and eliminate another variable. Don't keep solving in terms of another variable because it gets real messy as you plug in. Solve it like this, real systematically. Take 1 and 3. You have to solve for z because we're going to match it up to this guy. So I want the coefficients of z to be the same number but opposite signs. So what should I multiply the top equation by? Okay, you can do that one by -5. And then Raven, what would you multiply your bottom one by? 3. Okay, all the way across throughout the equal sign. So -5x plus 10y, whoops, plus 10y minus 15z all the way across equals -45. Multiply the 3. 6x minus 15y. Here's what I was looking for. Plus 15z equals 51. Now, add them down. This becomes x, -5y, out goes the z's, and equal to 6. This is one I combined. Now, if I had to, I could do 2 more, eliminate the same variable, and combine those 2. But my goal was so I can combine this with equation 2. Because equation 2 has a z missing already. And if I add those down, what will I eliminate? X. So add those down. Divide by -2. And y is equal to -1. So keep track. Oops, we don't know x. Okay, so now, we back solve. Go to one of the ones you just used and solve for now for y. What would be the best way to do is go for the one that we were given here. We didn't change it at all. So we're going to take this one, we're going to substitute into this one for your y, and we're going to solve for x. We're going to add 3. Therefore, x is equal to 1. And back solve again. Go to one of the original ones. Which one would you like to use, 1 or 3? 3? Okay, we'll use 3. You pick the one with the big numbers. So 2 times 1 minus 5, be careful, that's a negative 1. Oops. My board a minute to come back. So this gives me 2. A negative times a negative is a positive. Subtract. Therefore, Z is equal to 2. Now, you can give me your solution like this, or put it in the XY order. Okay. And let's put this in your matrix and see if we get the same thing. So we pull up your matrix. We do second matrix. And let's edit. Let's edit B. So it's, what's the order of these matrices? Rows, columns. Okay, let's try 4 by 3. Oh, I got 4 rows, 3 columns. So we just go right back up there, and we say, okay, 3 by 4. But you really can't miss. And that looks more like it. So we enter in your coefficients. Watch your negative signs. And you don't have to go to the next row, it automatically goes for you. But you do have to enter a 0 in for a space holder for your Z value. Hopefully mine all went in. Most important, you have to remember to stay quick. Then do your calcs on this, and your RREF on this one. And we used matrix B. And again, there's your X, your Y, your Z. So you can check it. Okay? Remember, if it's not going to have a solution, then this is not going to have a diagonal here. You'll usually see zeros across the bottom, or you'll see something weird looking. You want to look for this diagonal of 1s. That's where the X is, that's where the Y is, that's where the Z is.